Hi, my name is Johanna Schmidt. I'm with the VRVis Research Center in Vienna in Austria. We are working on application-oriented research in visualization, and today I will outline our ideas towards using visualization in notebook interfaces, which I developed together with my colleague Thomas Ortner. The landscape of data analytic workflows has drastically changed within the past years. This has led to many users in very diverse domains being confronted with new needs for data analytics. Due to the diversity of the user group, scripting languages like Python and R and Matlab have become more popular than ever. With such a diverse user group at hand, it has become more and more obvious that data workers prefer narrative approaches for data analysis. Such literate programming tools have several advantages. They help the data workers to record their steps and decisions they made in a data analysis workflow. Typical literate programming tools are notebooks. Notebooks consist of smaller elements, typically called cells, which contain portions of code. The cells can be executed independently, but variables may be shared across them. All cells together describe the complete data analysis workflow and all steps that have been executed. In this way, literate programming sessions can be saved and restored so that users can recall the workflow at any time. We wanted to explore the differences when using standalone visual analytics tools and when using notebooks. For this, we selected a data analysis use case and then used two different tools. In our case, the standalone visual analytics system Visplore, which was developed at the VRVis, which you can see on the left side, and the Python Jupyter notebook, which you can see on the right side. As a use case, we have chosen the analysis of time series data. The analysis of time series data covers a lot of different aspects, like you need to understand the structure of the data, you need to find interesting patterns in the data, you might want to compare different time periods, and so on. In the paper, we discuss different steps of this workflow, but in this talk, I would like to concentrate on the task of pattern search. Pattern search means that you have an input or a search pattern, and you would like to find all occurrences of this pattern in the given time series. So we will now have a look on how the pattern search task can be solved in a standalone tool and how it can be solved when using notebooks. In the standalone tool, Visplore already provides a predefined dashboard for doing a pattern search, and it provides a basic pattern search algorithm which is based on dynamic time warping. So given that the pattern was already selected in a previous step, we now search for all occurrences, and all the occurrences of the pattern in the given time series are marked with color. In addition, the detected patterns can also be overlaid in one plot. Users can also vary a sensitivity threshold with a slider, so to change the sensitivity of the algorithm so that more or less occurrences of the pattern can be found in the time series. So Visplore provides a lot of features to support the users when doing pattern search. But if we change anything in the workflow, if we change the sensitivity threshold, or if we change the input pattern, then it's very hard to keep track of those changes. We have to do it manually, we have to restore the sessions, or we have to keep track of what we already tried out, but it's not built in the system. In a standalone system, we are also limited to the features that are provided by the system. So in that case, if we would like to try out another pattern search algorithm, then it's not possible. So in the case of the notebook, we use Python Jupyter notebooks, and Python provides several different libraries for doing pattern search in time series. In that case, we selected the mass-TS algorithm with GPU acceleration for doing the pattern search. And The results are also quite fast, but if you would like to display the results, we have to do it manually. So we don't have the support that a standalone system offers with predefined plots and views. We have to do it manually here. But on the other hand, if we would like to try out different parameters, different input patterns, or even different algorithms, it's very easy to do it in a notebook because we just put all the things in different cells, and then we can easily keep track of what we already tried out. And it's also very easy to compare the results because we can simply plot them underneath each other and then compare them. And although notebooks provide all those built-in features, the integration of visualization techniques in common narrative programming interface, like the Jupyter notebooks that we use, is still very limited. And as a consequence, in most of the cases, data workers end up using only some well-known basic charts, while they refrain from applying advanced visualization techniques. This is especially true for the iterative exploration of the data. At the same time, data scientists express their interest in applying new visualization techniques and in applying more advanced visualization techniques. We therefore argue for a stronger focus on notebook interfaces when developing new visualization techniques. Of course, such a close integration is also not that easy to achieve. There are several technical limitations and barriers that we identified which can hinder a better integration of visualization in notebooks. Nevertheless, since we can access such a large community of data scientists and data workers, we think it's really important to work on a close integration of visualization in literate programming environments. And for this, we identified several possible directions for future work. The first one we called is placing visualization in the data workflow. Here we mean that we need standardized interfaces between data visualization and data analytics. Another important thing we identified is the development of new domain-specific languages. Because domain-specific languages will allow the expert to really specify what they want to see, instead of being forced to focus on how they achieve an intended goal. Similar to the standards for input and output data, we should work on standards for user interaction in visualization. If we have standards like that, it would be easy to integrate the visualization in the notebook. And also with the standards, users would immediately know how to interact with the visualization, which interactions are possible, and which interactions would create which kind of output data. Another important goal we identified is guidance. So to many users, it's not natural to formulate their goals in code. They know what they would like to do, what they would like to see, but they don't know how to formulate it in programming code. The last thing we identified is the incremental evaluation and execution context. Especially in scripting environments where the computations might take longer and might be very expensive, it's very helpful for the users to get parts of the data visualized to see whether the result is as they expected or not, so that they can either skip the process or wait until the visualization is ready. So to summarize my talk, we really argue for a better integration of visualization in literate programming environments, because this way we can address a very large community of data scientists and data workers who really have very interesting use cases for us to work on. Thank you very much for watching.